The target problem we'll be assisting a student with is an optimization question. The problem is asking the student to solve for the width and height that will give the greatest strength of a rectangular beam. However, we are only given the radius of the cylinder as well as the proportionality of the width and height as WH squared. A difficulty our student had with solving this problem was understanding the relationship between the variables, specifically in setting up the correct equations in order to solve the question. From the problem, he understood that W represents the width, H the height, and S the strength. However, he misunderstood how, from the equation and its derivative, S is equal to KWH squared, can be solved for maximum strength. Overall, it is easy to understand these questions as known equations that can be combined to solve for what you're optimizing. For example, adding the volume of the cylinder to the surface area for total material used. Therefore, in order to solve this problem and other similar ones, an understanding of how common shapes and their formula can be connected is an essential strategy in comprehending the question.
To overcome these difficulties, we use writing down all relationship strategy because relationships between these variables are important and complicated. From the question, we see that the strength of a beam of width W and height H is proportional to W times H squared. So S equal to K times W times H squared. And we notice that there is a triangle in the circle, so we can use the Pythagorean theorem to identify H squared. Then substitute H squared into previous function, so we have S equal to this one. And to find the maximum strength, we first calculate the derivative of S and find the critical point where the derivative of the strength is 0. And we should make sure the derivative is greater than 0 on the left side of the critical point and less than 0 on the right side, so there is a maximum point. After that, we can conclude that the dimension which maximum the strength. So don't forget the domain W and H are both smaller than 60. Writing down all relationships can make the problem clear and easier when there are too many variables. Also, when you list all relationships you need, it will offer you the idea about how to solve this problem. And you can check which relationship you need whenever you want. It is an effective way to reduce the mistakes.